Now we have advanced physics for all top exams, and we have vectors 3 now. Addition, or you can call it summing up or finding the resultant of vectors. When two vectors are in the same direction. So we have different ways we can, different situations we consider. First we consider when two vectors are in the same direction. In such a case, we simply add the magnitudes and the direction is the same for the resultant vector too. This is plain and obvious because two vectors, let us say two forces acting on a body in the same direction with two magnitudes have to be simply added arithmetically only, isn't it? So when two vectors are in exactly the opposite direction, in such a case we simply subtract the magnitudes and the direction for the resultant vector, the final vector, is the direction of the one vector which has the larger magnitude. This also is plain and obvious because two vectors, let us say two forces, 5 units and 10 units, acting exactly in the opposite directions on a body will have what resultant? Will have a resultant first of magnitude 10 minus 5 is equal to 5 magnitude, and the direction will be the 1, yes, for the 10 units because that's larger. For the vector that has 10 units, 10 being larger than 5. So this is very clear. Same directions added, opposite direction subtracted, give the direction the opposite direction of the one which has a larger magnitude. When two vectors are inclined at some angle, here we do the geometric way. We take the first vector, let us say 5 units, as 5 centimeter as a horizontal line on paper. The other vector also we do the same thing, but we put the tail of the second at the head of the first vector with the angle of 60 degrees. So we have now first vector as AB and the second vector as BC. So the result will be resultant will be AC, and that's clearly seen in the figure. Measure both the magnitude. There is a length of AC and the direction as the angle from the horizontal. So AC you measure totally, as you see in the figure, and CAB, angle CAB or BAC is the direction of the resultant vector. This is also called the triangular law of vector addition. As you can see, we are completing the triangle. We can also do it in another way to get the resultant. It's almost the same parallelogram law of vector addition. Here we, as you see in the figure, we put both vectors at the same point. So you have OB and OA, 5 centimeter, 10 centimeter. We have just given some numbers here, 60 degrees to take one example, and complete the parallelogram. So you complete by BC and AC. We can easily show that with this geometric way, we can also use algebra. We don't need to do geometry. We don't need to take a paper and put the 5 centimeter, 10 centimeter. We can do it algebraically. How? Use the Pythagoras theorem and you can easily derive that R square, resultant square, is equal to A square plus B square plus 2AB cos theta, and the direction tan alpha is COA, and COA, and the resultant is magnitude is OC. So what is the resultant? OC is the resultant, COA is the direction. So that will be tan alpha will be B sin theta by A plus B cos theta. So as simple. And what is theta? Theta is a full angle between the two vectors. BOA is theta. BOA is theta. So it is beautiful. See how man has used a certain simple geometry and simple algebra to find out how to add vectors which cannot be added arithmetically because it also has angles and directions. Angles and directions means the same thing. Thank you.